got a 911 call from the woods, and when we came, we found her.
Is she unconscious?
We don't know.
You okay, man?
Yeah, I was just running through the woods and somebody hit me in the head with a book. And then they screamed that because I got an A+, they got an A- in our class. I didn't see who it was.
Did you guys find the book?
I think it's that one. Well, if this is the book that the attacker used, there might be fingerprints on it.
Yeah, we should check it.
I'm not seeing it. There's a hair in it.
Let's look at it.
This hair is long and black. Our victim is blonde. You think this is the hair from the attacker?
It must be.
But how can we use it to identify someone? There must be tons of long, black-haired kids in bio.
You think there's some kind of DNA on that?
Probably, but how do you get DNA out of hair to use to identify somebody?
You gotta use some kind of DNA fingerprinting.
Yeah. How do you get that?
Hey, look. What's this?
Gel electrophoresis? You think you can use that to get a DNA fingerprint?
I think we should. You think there's someone on campus that can do that?
I think I know a professor who does that in her research.
We should go check it out.
Yeah. Let's go.
Okay.
We're investigating an attack that happened, and the only piece of evidence we found was this hair.
Okay, well, it's important that you got the hair roll in the hair because that's where all the DNA is contained. We will isolate the cells from the hair bulb of the hair and extract the DNA.
Or once you extracted the DNA, how would you, what would you do with it?
We will put it through a series of markers that we know that individuals have different genetic background. Another type of polymorphism are VNTRs, which are variable number tandem repeats. There are thousands of these VNTRs across the human genome. If you look at different VNTR regions, the probability of two people having the same pattern of VNTRs is low. We find a suspect, we find a group of people, we'll check their same sites.
We read something about a process called gel electrophoresis, which is a way to map out those regions. Do you know how that works?
What we'll do is we'll take the DNA and we will digest these with common restriction enzymes. The first part of this process is we chop up the DNA, we run it through a gel electrophoresis, we separate the fragments based on size. And then you can visualize this by developing this on an X-ray photographic paper. And then you see a series of bands.
We should get to the lab.
A sample of the hair of all the suspects is taken. Because each person's DNA base pair sequences are unique, each DNA fingerprint becomes the only one of its kind. These are compared to the DNA evidence found at the crime scene. A match of the DNA patterns is made and the true attacker of this crime is identified. DNA technology will solve the mystery of the crime. Without this knowledge, we won't be able to convict a criminal with such compelling evidence. It is an important aspect of science, but also an integral part of other areas. It can not only be applied in forensics, but in a wide range of pharmaceutical products, environmental cleanup, diagnosis of disease, studying and altering genes, and even agriculture. Learning and developing research of DNA technology is essential in understanding these diverse fields.